All right, people are talking about foiling this thing out, and I think that just gets in the way. They want to know what the derivative dy dx is, so let's just implicitly differentiate straight out. I'm going to think of this as x plus 2y to the 1/2 power plus 3xy to the 1/2 power equals 11 point something. I don't even care what the something is, because what I'm about to do is I'm going to take a derivative, and that whatever that constant is going to go to 0. So I'm going to take the derivative of the left-hand side with respect to x plus the derivative of the right-hand side with respect to x. A little 11 point something. Right? Again, I don't care what that is, because that side is beautiful 0. We'll just say equals 0 on that side. That's a constant. Now, the thing is, this is just something to a power. So we're going to do the power rule here. So 1/2 times x plus 2y to the minus a half times the derivative of the inside. Now the inside is x plus 2y. So I'm taking the derivative with respect to x. So that would be 1 plus 2y prime, or dy dx, however you want to write that. So that was a power rule followed by a chain rule with another chain rule in there, in the sense that the y is a function of x, so the y prime. Plus, same thing over here. This is also something with the half power, so 1/2 3xy to the minus a half power times the derivative of the inside. This is now a product, 3x times y. So I'll have 3x times y prime plus 3 times y. Right? So I thought of that as 3x and y. So that's that product. Now it's just a matter of solving for y prime. I see two y primes in here. Actually, I do a double check, because the original equation had two y's in it. So I better see two y primes. And I do. I saw one here when I took the derivative of that y. And I see one over here from taking the derivative of this y. So I'm going to have to distribute some things through here first. Let's write this as 1 over x plus 2y square root times 2, plus the 2's are going to cancel out, 2.5. So this is just y prime over x plus 2y square root, and just distribute that through. So I've got a 3xy prime over 2 times the square root of 3xy plus, and then there's a 3y over 2 times the square root of 3xy equals 0. I see two terms, this one and that one, that do not have, this one and this one, which do not have y primes in it. So they go over to the right-hand side, and then these two are going to factor out. So I'm going to have a y prime times 1 over 2x, no, x plus 2y into the square root, plus, what do we have here? 3x over 2 times the square root of 3xy. I'm going to just do something here. I'm going to throw a 2 in this denominator and a 2 right there, because I see I'm going to combine those before I get them over the other side. Equals, and I'm going to move these two guys over here. So I've got a minus 3y. Both of them already have the same denominator. So minus 1 over 2 times the square. No, they don't have the same denominator. Not sure what I was seeing. These are definitely different denominators. So I'm gonna not do the 2 thing. So this is still a 1 right there. This is just this one coming over. So, and then minus this one coming over. So 1 over 2 times the square root of x plus 2y. Now, just divide by this stuff right here. So I've got y prime equals all this stuff minus 3y over 2 times the square root of 3xy minus 1 over 2 times the square root of x plus 2y, all over all of that stuff, which is 1 over the square root of x plus 2y plus 3x over 2 times the square root of 3xy. Now, it's possible this could be simplified, I guess, but what I wanted was the derivative at a particular point. So let me go back. What point was that? I wanted 4, 5. So at this point, rather than simplifying it with letters, let's just plug the 4 and 5 in. So this is at 4 comma 5. This thing's equal to, so negative 3 times 5 is negative 15 over the square root, or sorry, 2 times the square root of 3 times 4 times 5. 4 times 5 is 20, times 3 is 60. Minus 1 over 2 times the square root of 4 plus 10, all over 1 over the square root of 4 plus 10, plus, what do we have, 12 over 2 times the square root of 60. Whatever that's equal to, you can type that into your calculator. But the thing that was causing people problems is they wanted to get rid of those square roots to start with. And squaring both sides doesn't do it. Squaring both sides of this thing does not get rid of that square root. It would, if you did square both sides, let me just show you what would happen. If you did do the square root of x plus 3y plus the square root of 3xy, and you squared that thing, then you FOIL it out, so you got the first thing squared. Well, that would just be an x plus 3y plus 2 times the product of both of those, x plus 3y times 3xy, plus the last one squared, which is 3xy. And so this would still be equal to that 11 point something squared. And when you take implicitly differentiate now, you still got to deal with that square root. You're going to have a bigger product rule. You got 4 y's in there now, so you're going to have 4 y primes. It's just going to be bigger. So I think the thing to do is to not square it to begin with. Okay. Anyway, the answer is that once you type it in your calculator and see or simplify it first, whatever. But there you go.